Now let's talk about the measurement of humidity. So humidity is most often measured through automated instrument, although some of the instruments, backdated instruments, are still taken manually at some observing unit. One common instrument used to obtain dew point and relative humidity is psychrometer, which consists of two liquid in-glass thermometer mounted side by side and attached to a piece of metal that has either a handle or a chain at the end. The thermometers are exactly alike except that one has the piece of cloth, or we can say wick, covering the bulb. The wick covered thermometer is called wet bulb thermometer, and it is dipped in clean, usually distilled water. So while the other thermometer is kept dry, both thermometers are ventilated for a few minutes, either by being wired sling psychrometer or by having air drawn past it with an electric fan. So that is called aspirated psychrometer. Water vapor rate from the wick and the thermometer cools. The drier the air, the drier the amount of the evaporation and cooling. After few minutes, the wick covered thermometer will cool to the lowest value possible. So we know that this is called wet bulb thermometer, the lowest temperature that can be attained by evaporating water into the air. The dry thermometer, commonly we call it dry bulb thermometer, gives us the current air temperature, or dry bulb temperature we call it. The temperature difference between dry bulb and the wet bulb is known as wet bulb depression. A large depression indicates that a great deal of water can evaporate into the air and that the relative humidity will be low. A small depression indicates that little evaporation can be possible, and so air is close to saturation if the depression is smaller fraction or a small number. So the dry bulb and the wet bulb and the dew point would be same point if there is no depression. The wet bulb depression, if it is 0, so dry bulb temperature, wet bulb temperature, and the dew point would be the same temperature. So our relative humidity would be 100%. That means the air would be completely saturated. So let's see how do we actually measure relative humidity and dew point temperature by looking at chart. So in the right side of this slide, we have the chart for the relative humidity. So we have the dry bulb temperature on this line, vertical line, and this line is showing that's the wet bulb depression. That's mean the difference between wet bulb and dry bulb temperature. That's called wet bulb depression over this line. If we have this wet bulb depression and also have dry bulb temperature, intersection will say the relative humidity. So here the relative humidity is 67 and temperature is 2 degree. Wet bulb and dry bulb difference is um, if like 67 this one. So similarly, if we have relative humidity and we have dry bulb temperature, we also can find out the dew point temperature by looking at this chart. So if we have 80 degree Fahrenheit temperature and we have relative humidity is 60%, so our intersection 65 would be our dew point temperature. So following these rules for both chart, we can identify the relative humidity and the dew point temperature.